So we're still working with solving quadratics, and on this video we're going to focus on solving by completing the square. So here's how you know you want to solve by completing the square. So when you're going through these problems, first off, you always still want these equal to 0. But the first thing you want to look for is, can you actually factor t squared minus 8t minus 5? So we're actually going to try solving by factoring first. So you want to try and factor this. After you've spent some time and you realize you can't factor it, that means it can't be factored. So what we're going to do is we're going to solve by completing the square. Essentially what the strategy with solving by completing the square is we're going to rewrite this left side so that it can be factored. So we're going to adjust this and manipulate the problem so that we can factor the left side. So first thing we want to do is, even though it's equal to 0, and we've decided we're going to solve by completing the square, we actually want to move what is essentially our c, whatever doesn't have a variable attached to it, we're going to move it to the other side. So I'm going to add 5 to both sides. So what we're going to have here is t squared minus 8t, I'm going to leave myself a little bit of room, equals positive 5. The next piece is what is actually called completing the square. So we're going to complete this, that way we can actually factor this later. So what we're going to do is we're going to take b, we're going to divide it by 2, and we're going to square it. So in this problem, my b is just what's in front of my variable there, because it's like ax squared plus bx plus c, standard form. So my b is negative 8. So I'm going to do negative 8, divide it by 2, and we still have to square it. So negative 8 divided by 2, we're going to get negative 4. Negative 4 squared, we're going to get 16. What we're going to do with that 16 is we're going to plug that in that gap we just created. So I'm going to have a positive 16 here. The trick here, though, is I just added 16 to the left side of my equation. Earlier, when I added 5 to the left side, I had to do it to the other side. That same idea still holds true here. I have to add 16 on the left, and if I do that on the left, I also have to add 16 on the right. So my next line is going to look like t squared minus 8t plus 16 equals 21. So what I've done by completing the square is I've allowed myself to actually be able to factor this left side. So I have t squared minus 8t plus 16 equals 21. So what I'm going to do is factor this. So I'm thinking of two numbers that multiply to 16 that also add to negative 8. Two numbers that multiply to 16, but we add them, you get negative 8. We get t minus 4 and t minus 4 is our factors. Now, when you have the same thing there, what we can write is t minus 4 squared. So whenever you have the same thing multiplied together, you can write that as t minus 4 squared. This is still equal to 21. From here on out, I've gone from having two variables, variables showing up twice, t is here as well as here. So what I'm going to do is from here on out, I'm actually going back to one of my other strategies. I'm going to now solve using square roots. So I was allowed to rearrange this, factor it, and now I'm going to solve using square roots. So I want to get rid of this square. So I'm going to take the square root of the left side and take the square root of the right side. When you do that, taking the square root of a square, those are inverse operations. So I have t minus 4 equals, and then I have the square root of 21. So again, we want to go back to, can we simplify the square root of 21? So you're trying to think of a number that maybe we could take the square root of, that can divide in here. You're not going to find anything. 21 is not something we could simplify as a square root, so I'm just going to leave it as positive and negative square root of 21. So we're almost done here. The next step, I just need to get my t all alone here. So what I'm going to do is I'm going to add 4 to both sides. So I'm stuck with our t all by itself on the left side, and that's what we want. We want to get our variable isolated. On the other side, I have this positive 4 plus and minus square root of 21. Now, some people start thinking, well, can we add these or anything? We cannot. This is 4. This is square root of 21. They are not like terms. We can't add and subtract here. So this is rational and this is irrational, so we're not going to add and subtract these numbers. So what we get as our answer is just 4 plus or minus square root of 21. By the way, you can also write your answers as t equals 4 plus square root of 21 if you want to split it up, and t equals 4 minus square root of 21. These are the same thing. I'll accept either or. So those are our answers. So I'm going to do another completing the square problem, this time a little bit more complex. So I have negative 3x squared minus 18x minus 6 is equal to 0. Now how this problem changes from the one we just did is the original, we had our variable squared, but we had a coefficient of 1. We need that coefficient of 1, that way we can actually go through the process of completing the square. On this one, you'll notice I got this negative 3 out front. So these are different because now all of a sudden I have this negative 3 here. So what I'm going to do is I would like to get that down to 1. So I'm going to divide the entire left side by negative 3. I'm going to divide all of these terms by negative 3. You'll see why here in a second. Again, if I do this to the left side, I'm going to have to do it on the right side so I stay balanced. So I'm going to have negative 3x squared divided by negative 3. That will give you positive x squared. That is what we wanted because now I have that, how I had t squared originally up here, I now have this just x squared right there. That's what we want so we can complete the square. I'm going to do negative 18x divided by negative 3 and I get positive 6x. Negative 6 divided by negative 3, I get positive 2. And on the right side, I have 0 divided by negative 3, which is 0. So what I've done with that first step is I got from this new problem back to a problem that we should know how to do at this point. So I'm taking a new concept and reverting back to, hey, old topics that we should know how to do. So I'm going to go from here and solve using completing the square. So if I could factor that, I would, but I can't. So I'm going to divide by, or sorry, subtract 2. So I have x squared plus 6x, I'm going to leave myself some room, equals negative 2. Then from there, I actually have to do the completing the square process. So I have this 6 here. That's my b. So remember, I'm doing b, divide it by 2, and square it. So I'm going to have 6 divided by 2, and we still have to square it. 6 divided by 2 is 3, so I'm going to have 3 squared, which is 9. I'm going to take that 9 and plug it in to that spot right there. So I'm going to add 9. If I add it to one side, I have to add it to the other side. So I have to add 9 over here as well. So looking what I have, on the left side I have x squared plus 6x plus 9. On the right side I have negative 2 plus 9, which we get positive 7. So from here, I now just rewrote this so that I can actually factor it. So I need to factor x squared plus 6x plus 9. So I'm looking for two numbers that multiply to 9, but when I add them together, I get 6. So the numbers I'm looking for are positive 3 and positive 3, so I'm going to get x plus 3 squared equals 7. So x plus 3 squared is my factors there. Next thing, I just need to solve this for x. So I'm going to take the square root of the left side, as well as take the square root of the right side. When you take the square root of a square, you're left with x plus 3. On the right side, we're going to try and do the square root of 7. And you can type this into your calculator. You're going to get some sort of decimal. I don't want some rounded decimal. Let's just leave it as plus or minus square root of 7, because we cannot simplify that any further. Only thing left to do is try and get x all by itself. So I'm going to subtract 3. Subtract 3. So that's going to leave us with x equals, I'm going to have that negative 3 plus or minus square root of 7. And that is our answer, and that is completing the square. Again, as a quick review, the reason we're doing completing the square is we run into our quadratic equal to 0, and we realize we cannot factor it. So completing the square is a way to allow us to be able to factor this and solve for x.